Okay guys, for the second method, let's look change of sign method. Okay, so for change of sign method, okay, so the concept is that, okay, so for our syllabus, what they will ask us to do is, normally questions when given, they will give us with a certain interval already. Okay, just say a and b. This can be anything. I'm just naming it as constant a and constant b. Okay, so they will already give us an interval, and we will just need to confirm it. So it's just all about confirmation. We just need to confirm that their statement is correct. We just need to confirm that the interval of roots of a certain equation is in a b. Okay, that's it. Okay, so how we do it is, they'll already give us an equation. Okay, so let's just say y is equals to x power 4 plus 2x plus 3. Okay, let's just say it's this. So we'll need to confirm that the roots of this equation is in interval a and b. Okay, so what we do is we just substitute value a and value b inside x. So let's just say fa, we substitute and we get a negative value. And just say then next we need to substitute fb equals to, just say, a positive value. Okay, here will be negative, here will be positive. Okay, and only then the roots of the interval is located with, it is correct that the interval is located in this root. If just say, okay, we've substituted both the values and we get here, just say this side is positive and this side is also positive, or this side is negative and this side is also negative, that means that this is not the interval. Okay, why I stress that one should be positive and the other one should be negative is because, okay, let's just say this is a graph. Okay, and okay, let's just say we know that our root is located at 3. Okay, and then this is just say a, this is b, as given the interval just now. Okay, and then just say this is a linear function and the graph goes like this. Okay, so now we know that this is negative and this will be positive. Okay, so this is why we have to make sure one should be negative and one should be positive. Okay, it doesn't matter if a is negative or b is positive. Can be also that b is negative, a can be positive as well. Okay, it doesn't matter, but we should always make sure that one is, when we substitute the value, we get a negative value, and another one should be a positive y value. Okay, so that's what I've been saying. So this is why. So one, we know that one is on the other side of the x axis, the other value is on the positive side of the x-axis. Okay, so basically that's the concept of why we should make sure one is a negative value and another one is a positive value. So once we've gotten this, we should make a proper conclusion, just the same as the graphical method. Okay, so how we make a conclusion? Okay, so for that, let's look at an example first. Okay, so as we can see here, example 2. Okay, so the question is asking us to show, as I said, this is just for our syllabus, it will be just confirmation. So show that the equation e to the power of x cos 2x equals to 2 has a root that lies in the interval of 2 and 3. Okay, so this is confirmation that it lies in this root. Okay, so first, by using the change of sign method, okay, we just write back. So what we do first is, as you can see here, we just put 2 over here and then it will be equal to 0, and then we label it as fx. Okay, so first thing is we substitute the first value of the interval, which is 2. Okay, we substitute 2 into the x values of this equation. Okay, so when and okay, sorry, let me highlight this. Okay, so as we can see here, this is a trigonometric function here. Okay, so this term is trigonometric term cos. So we should always keep in mind, so when substituting the value inside the calculator, we should always make sure it's in radian mode. Okay, always in radian mode. Okay, so then we just substitute the two value inside x, put it inside calculator, and we will get, okay, as here we can see the value we get for f2 is negative 6.8298, which is a negative value. So we just I've written it back as negative 6.8298 is lower than 0, which means f2 is lower than 0, which is a negative value. Okay, so then we substitute the other value of our interval, as just now was 2 and 3, so we substitute 3 now. So we get positive value, which is 17.2855, and then we can get as f3 is more than 0, which means it's a positive value. Okay, so then next we just make a conclusion, a simple conclusion. Okay, so the conclusion will be, since f2 is lower than 0 and f3 is bigger than 0 or more than 0, thus the equation, okay, we just state back the equation, has a root that lies in the interval of 2 and 3, and so we just confirm it. So it is true that the equation has interval that lies in 2 and 3. Okay, so that's just about it, we just confirm it. Okay, so that's it for change of sign method. So next let's look at questions or exercise that we can work on. Okay guys, so now for the second method, which is the change of sign method. Okay, so let's see how do we solve this type of questions. Okay, so for the first question, let's read and understand the question first. Okay, so show that the root of equation 2 ln x minus 2, which is equals to 6 minus x, lies in the interval of 4 and 5. Okay, so for this, as I said just now, we just have to make sure one value is positive and another one is negative, or vice versa. Okay, so how we go about this question first is, let's make it all towards one side first. So this one we push it this side, or this one you bring it to the other side also can. It's up to you. Okay, so I'll make it into this form first. X minus 2, which is negative 6 plus x. Okay, so now we have made it into this form. Okay, so then next step what I will do is I'll just make a statement by using change of sign method. Change of sign method. Okay, this is just a statement, so if you want to make, you can go ahead. If you don't want, you just want to ignore this part, it's up to you. Okay, so now when x is equals to 4, okay, we just substitute our first value, 2 ln 4 minus 2 minus 6 plus with 4. Okay, we just substitute in this in our calculator, and we will get a negative value, which is negative 0.61371. Okay, so and then the next step, we just make our statement again. This negative 0.61371 is lesser than 0, thus f of 4 is lesser than 0 as well. Okay, so now we've known the first value when we substitute in is a negative 1. So now we have to make sure the second one, which is f of 5, is a positive value. So now let's go for that. Okay, when x is equals to 5. Okay, so 2 ln 5 minus 2, and minus 6 plus 5. Okay, so now when we substitute this value inside the calculator, we should get a positive value, and yes, we do get a positive value, which is 1.19722. Okay, so it's a positive value. Next, we make our statement as well. 7 to 2 is more than 0. Thus, f of 5 is bigger than 0 or more than 0. Okay, so now as we know here, one value is positive and another one is negative. So it is true that the root of interval is in 4 and 5. Okay, so lastly, we just make our conclusion for this. Okay, so since f of 4 is lesser than 0 and f of 5 is bigger than 0, thus it is true that the equation, which is 2 ln x minus 2 equals to 6 minus x. Okay, this one we take from the first part, okay, from the question itself, as root that lie in interval of 4 and 5. So that's it. That's how we go about our conclusion. Okay guys, so that's it for the first part of this video. Okay, I hope you understand everything that I've taught so far. If you have any questions, you can leave it in the comment. I'll come and check it and I'll respond to it as well. So I hope you understand. I'll meet you in the next video. Thank you very much.